Okay, now we want to determine the characteristic of image by graphical method and formula. So first I will show you how to predict and analyze image characteristics for the convex lens. So here, for example, you are given the focal focal length of your convex lens is 10 millimeter, 10 meter, and consider the first case. We have three cases actually to be considered, 1, 2, and 3. So let us consider the first case where the location of the object is more than twice of the focal length. So the focal length is 10, so 2 times 10 is 20. So that object which is far away from lens, for example this lens, if this lens it has a 10 meter, so this is suppose that it has 10 meter, so the object is very far than twice of the object of the lens. So how do we start is that let us draw optic axis, and then draw let's say this is a convex lens, and then mark, for example here I mark 2 box for 10 meter. So this is 10, so this is 20, and this 30. Sorry, and let's put our object 25 from the lens. So objects we represent as an arrow and mark it as O. Alright, then we need 2 rays to indicate where is the position of the form object image. So the first ray is one ray which is parallel to the optic axis, and then what happened to this? We have seen previously that so this is important. We have seen that the parallel rays will focus at the focal point. So that means we have to bring this ray to the focal point like this, and then this is the first ray. The second ray is one from the object directly to the center of the lens without any deviation. Okay, so the image will be formed here. So the ray from the head of the object will be formed here. So we have image which is inverted. Okay, so why we have these straight lines? Let us recall back to our drawing here that we have previously discussed. When the lens is very thin, so very thin, the ray is almost in a straight line. So that's why we make this as a straight line. So the intervention between this ray will form the image location. So this is image. So what are the characteristics of the image? Is first, when you compare this and this, it is smaller in size, the orientation is inverted, and it is real. What does it mean by real? Real means that outgoing rays, this is incoming ray, incoming, and this is outgoing ray. The outgoing ray pass through the image, so we have a real. Okay, this is for using graphical method. if we use the formula, so like this, we have this formula 1 over f equal to 1 over s equal to 1 over s prime. So you put the value for the focal length, the position of the object, and we want to know where is the position of the image. So from this calculation we have 16.7. so is it true? So if you look here, okay, it is coincidence. So that means both technique can be used, graphical or math formula can be used to confirm the location of the image. And then the magnification is the image position divided by the object position. So make sure this negative is available. So you put down this is 16.7 divided by 25. So we have negative 0.67. So if m is smaller than 1, means the image is smaller. And if it's negative, it means that the image is inverted. Alright, so let's move to the case number 2, where the object is closer between this 10 and 20. So this is the case number 2. So let us repeat again. The optic axis. Okay, 1 2 3. Okay, and then sorry, so I'll use the different okay, anyways, and we have the concave lens, convex lens. So let's mark our important points here. Alright, so the object is position is 15. Suppose it is 15. That means between these 2 points. Alright, now we want to draw the ray diagram. Again, we have a light which is parallel and go to the focal point. So this is the first ray, and the second ray is the ray which is oh sorry. So okay, so we have here, maybe this is about here. Okay, okay, so it is a little bit out of our range. Okay, yeah. Okay, so if you look into this, we have the image is about here. This is our image. What will be the characteristic? It is larger and inverted, and lastly is real. So they have the similar, almost they have only one difference. Both are inverted and real, and for this case we have larger. So let us confirm by using our calculation by case number 2 here. Okay, so the same f, now it is closer 15, and we have the object is positioned at 30 meter. So our, yeah, it is nicely predicted our answer for the image. And for the magnification, so plug in 30 divided by 15, we have minus 2. Minus 2 means the magnification is twice larger and it is inverted because of this negative. Okay, next, if it is really close, if the object is brought very close to the object, okay, let us draw like this and like this. Okay, so 1 2 2, and now the object is really close like this. Alright, 5 meter example here. So let us draw the, so it's a parallel and being focused. Another one is go directly to the center So we see that we don't have any intersection of rays. But if we look from here as compared to here, so if we look into here, it seems that we are looking some of the interpolation, it's extrapolation of the ray behind. Okay, so that we have the intersection here. Okay, the image is seems to be formed at the same side as the object. So we have a larger object, a larger image erected, and also it is visual. So why it is visual? Because this is outgoing rays. Outgoing rays is on the opposite side with the image. So image and outgoing rays are on the opposite side. So we have visual. Now let us confirm by our calculation. So you have here is same, only here it is closer to the lens, so we have minus 10. So minus 10 here means that the image and the outgoing rays are on the opposite direction by sine rule. So this is opposite direction. Okay, so we have nice, this is minus 10, so it says looks nice. This is 10, this is 10, right? 20, 30. And then the magnification, you put the same way, but beware of this negative, because we have here negative. So we put it inside here negative, so we have positive 2. So it is twice, and it is erected. Okay, so now we have finished with the convex lens for 3 different cases of object. Closer, this is very far, then twice, this is 20. Then if the object move closer, image become very large, inverted aerial. And then if it is very close, it become very big. So this is important for later in a chapter optical instruments, because this is the basic principle of simple magnifier. Simple magnifier like this. So we can see it's larger. Yeah, this is larger compared is like this, because this is object. So this is object, and the object is within the focal length, because the focal length of this is about 30. So if we put anything between this and its focal point, the image will be larger and on the same side. Okay, so you see it's larger and in the same side as the object. And it is visual because we cannot touch the image. If you put like this, you are touching the object, not the image. Alright, so later we will continue to the concave lens. This is wrong.